Look like we're live. So, welcome to another game night. We're going to go through, I think, one puzzle. I think I only have enough in me to do one puzzle tonight, but we'll see what we can do. So, we're going to go do this Three Kingdoms puzzle. We're going to open design and see what we got. I'm trying to remember how to move around this screen again. There. Why? There we go. So, here's our screen. I'm going to turn the music down a little bit. Let's go over specifications. In 1, in 5, and 12 are simple inputs connected to a mechanism that accepts, detects tokens. So we have different tokens. Bell is a simple output right there. Alpha are symbols connected within the defenses, one or two tokens. After a sufficient number of tokens have been inserted, the payment key is to ring the bell and dispense change is authenticated in the verification tab. Okay, cool. So very simple outputs and a price. So ring the bell and change. Okay, so we have 16, and then it's just 16 minus what? We have two 12s, and I see 8. 24. Okay, yeah. Is there anything else in this verification tab you can? Okay. So we're gonna say um do one to count, right? And one for the bell. Oh, we need simple inputs. Huh. And is this a simple input or output? Let's see. Why are those all X's? Okay, so this is an X. Um, so we want sleep X0, uh, um, move X0 to ACC, delete 1. Anybody remember instructions? Because I don't. Okay, it's an MOV. MOV. Simulates. Reset. Okay, so let's step. So that's 1. That's good. Um, okay, reset. Enough code in here to count up to 16. And then decrease down to 16. I say, yeah, let's pull in the big boy. I want to state. Uh, I might have enough to do that. But yeah. Okay. So one is one. So basically, we're gonna sleep until x1, and we want to do some. We want to do the compare tutor. Where is my compare? So we're going to do a TCP compare. TC compare. So we're going to move a 1 into ACC. Oh no, we're going to move X1 into ACC. Yeah. Then we're going to do. We're going to move. We're going to move X1 into ACC. No, we want to move 5. We want to move 5 into ACC. Then we'll do compare. What? TCP. X1 and n. If it's less than, we're going up. If it's greater than, we're going to move a 12 into ACC. If it's less than, we're going to move a 1 into ACC. And then we're going to add ACC and do that. And what add features do we have? Oh, so let's say we want to store these in dat and then say add we want to say add dat and sleep 1. Sleep 1. And you are just going to sleep 1. Advance. Oh, handle the 0 case. So how do we handle the 0 case? So you think we should put 1 there, right? And we want to say instead of compare, we want to say if it's greater than, say if it's greater than 10, we add a 12, otherwise we move in a 5, x1. Now, otherwise it's going to boost to 5. We need a condition where it doesn't change. How would we do that? So you think we should put 12 in here, and if it equals 10 x1 EQ. So if it equals 10, we'll move a 5, otherwise we move x1. Oh, no. 4 different stages. How can we use this one? The first 2 stages are of the value. The way we can do that. I don't think I can. I can't think right now about how to do that. Because x1, this is true. I don't know. I see. Should we just do the naive approach? The naive approach does not sound fun, but it could work. We do this at 5. Well, 1. And we just say, no, we need to let it come. Okay. And we'll just do a quick equals here. X1 equals 0. Then we're just going to move 0. Right. Reset. Greater than. This is greater than now. X1 is greater than 10. Reset. Okay. Now if we're gonna say greater than, is it equal to or greater than? So if it's greater than can't do like a -1 trick, can I? Embedded systems are really annoying. I don't know. That would be less than, and then we do a negative. Is less than, if ACC is less than x2 minus, if x2 is less, no, this is false. We're going to move a 1 over x3, and you're just going to sleep on x0 and move x0 to ACC. We said plus 0 to x3. Okay, and so now we want to say x0 equals 1, then plus ACC yeah, want to move a 1, 2, 3, 4, a 4 into ACC. Greater than, if ACC is greater than 0, move 100 into P1 and Sub ACC. Sub 1. B1 plus sub 1. Advanced. Target greater than 0. Let's subtract work. Subtract the value of the first one from the value of the answer is the result. Oh, minus sub x2. That minus mu is 0. Yeah. I always feel like okay, reset. So what we're gonna do is we're gonna move these things around real quick. Um, um, do 0. Grab one of these things again. Okay. Sub x0. Move ACC to x0. Leave on x0. I don't think we actually need that one, right? One. We need that. Delete one. Delete one. Reset. We gotta move x0 to ACC. Oh, I see what it is. Reset. So do we actually need that one? Oh, this is move x2. Okay. Okay, reset. And what we want to say. I think we're fine there. Move ACC. if greater than, so less than, if ACC is less than 5 minus, this is true. What are we gonna say? We're gonna say move move 100 into P1. Do that. Yep. Jump and 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 what plus? Because it's already this move on him, and we need, oh, we probably should just do a move 0 into P1, move 0 into P0, and then sleep 1. Yeah. Is greater than 0. ACC is greater than 0, yeah. Let's do a plus, move 100 into P0. And if that's not true, move A0. Oh, we're not going to write to it all the time. How do you do that? I don't know how to skip a write though. Right? This is going to not update when we want it to. Let's see. Is it like a non-blocking read? Like if we do blocking, right? Like X bus is always blocking. I don't like those. We could just add a plus here and move a 0 to x2, right? And what we can do here is we can just do that, right? We're just going to add, no, just add x0, right? Yeah. Um, add x0. Yeah, it's the issue. Is we want to equal 0. what we want to do here is we want to do a plus, but we're going to move a 0 into P0, and a plus to jump start. Start. How we fix that? Well, if we're doing a sleep there, we don't need a sleep here. It'd be weird to have a sleep at the top, right? Yeah, that's why we can sleep at the top. Sleep colon. Okay, there we go. Oh, okay, we need another read here. How do we have too many sleep. Um, we want to move a start there. So week one, I could start here. And add x0. Oh, we got to subtract the values. Can we subtract it and then see if it's still there? That would be oh, this is going nasty code. I don't like it. I don't want to use a memory. Who knew such embedded code would be so bad? Less than so let's see right here. I'm going to try again, right? That's the best thing. Is a minus, we're going to sub 5. Then we're going to move 100 into P1, and we are going to move 1 into that. And what jump ends? You have an end somewhere here, right? And what equal AC0 minus move 100 P0 1 and I think we need a jump end. Okay. Oh, and we need to move one into that. Oh, and just gonna be a sleep one. And equals that one plus I need two here. Move 0 to P1. Jump. And cool. Oh, we forgot to reset. Enough room. Um, move 0 into that. Do I not need to do defaults because that would be so much better. Yeah, they just keep going. Uh, how do we do default? Um, I don't know. So it's like, yeah, the other solution, right? If we ignore the dat thing, right? We're just move a 0 into P0 and move a 0 into P1, right? The issue is that it jumps up immediately. That's not good. We need to space them. We could do a sleep 2, but we have a blocking right. Yeah, I don't know. This one's bothering me. Uh, and one line. We're just going to have to assume what, I should sleep 1 here. And we move a 0 into P0 and then move a 0 into P1. Well, we can put that one there. Okay, add x0 and then let's sleep 1. See, we get off there. Because we should only go here if we finish. But we're not using dat, so let's get rid of the dats. And what? Have a special, what, jump start here. Okay, start here. But need need a one here. Advance. Why is there not a? Let me see if I get this right. They're saying that we slept already. Added 8 there. Oh, sub 5. Oh, okay. So what we need to do is we need to start. You want to move. And if we could end there, it's just going to mess with our simulate. Yeah. Well, that's not what I was expecting. Oh, uh, move 0 into ACC. Oh, oh yeah, we want to sub X0. Move ACC to X3. Um, that okay. Now we have an issue where the remainder should have been erased. And we just move ATC there. And what? Um, so we need to zero out ACC. Oh, how we do this? How we do this? I am one line short of doing all these instructions, and I don't know why. Um, um, so add that. This is the better way to do that. We want to move a 0 into the other one. This one's really funny and annoying. I don't like how the right zeros per cycle. But I don't know how to do a non-blocking read await thing. Um, what do we do? Yeah, I don't know. It's x3 equals 0, add data. Which I understood this a little better. Or like, there's got to be better algorithms for doing this. Um, so what we go advance and show. Did I change something? Oh, this is supposed to be a minus. Oh, wait. I don't want to add a function just to do subtraction. Yes. Nope, no, we still can't do those. So yeah, we moved a 1 into x3. Any way we can condense these out? Ah, this is so frustrating. Like, yes, I would love to use these memories, but they are going to be a pain to figure out. So close. Seem to be going good. But we just gotta get rid of that value. Um, how do we get rid of those values? Do I have to write a 3 if we're just speaking it? Right? One or the other. Sheesh. Um, they're not a non-blocking read. I'm really getting annoyed with these blocking reads. No. We don't have enough lines to just say. Maybe there's a different strategy of looping back, performing operations, and reading. Um, is there a way to say ACC? And what we say, if it equals 0, well, it's gonna be a large value there, but then it should be 0, and we shouldn't have to carry about it. We do that. Right, we have everything but the bell working. And the bell, how do we just pulse a signal? How do I pulse a signal? Do we have like a pulse register? Just need a pulse signal. So, I mean, is there any way we can reduce this top portion? This top portion is just so large. We have a 100, 10, and we have a 0, 1, 10, and 100. And um so here's what I'm feeling, right? Oh, we can't subtract it. What can we do? Simulate. We can't be like, oh, simulate X1. And it doesn't. Um, what is a good way to convert that into a value? You know what? Yeah, we'll do it. You know what else we'll do? We'll be like, um, we're just going to have to bugger. Um, see. Um, we want something like this, but how do we get it there? I guess we could scoot this forward. We could scoot this forward. Scoot this forward. Scoot this forward. Back one actually. I'll put this one right here, and we're gonna move. We're gonna move. What's this? X0 into ACC, and subtract. We're gonna subtract 10. We're gonna subtract 9. Subtract 9. DC compare, right? ACC to 0. Um, and if then right here, so we're going to handle the first case, which is move X0 to ACC. If it's less, I don't know. If it's greater than, we're going to move x12 into ACC. If it's less than, we're going to move x0 into ACC again, and then we're going to move ACC to x3. Reset. Let's see how much. Sure. Wow, it's the most power hungry system I can make. Oh, fire. Reset. Advance. Simulate. Oh. Advance. 1, 2, 3, 4. Whoa. Reset. I made the most power hungry solution I could. Yay. Guys, look at that. Power usage. I dominated. Okay. What's this? This is the Three Kingdoms tokens. So our last treat tonight is we're going to look up a Three Kingdoms token. Three Kingdom token. Shenzhen I solution. Because I want to understand. Oh, Map Lab. See how he did it so quickly. Structure of token. Okay. Yeah, I can see that. So the first code, state, we're gonna move ACC. We have a loop here. Sleep one. Move X1 into DAT. X1 is concurrently. Oh, that's gonna be that thing. If equals 12. Yeah, I agree. Yeah. Yeah, that looks good. I agree. That's what we were doing. Jump loop. Um, Move x1 to dat. If dat equals 100, sub 12. If dat equals 10, sub 5. Oh, what they're doing is okay, I see. So they're creeping this value in ACC and they're subtracting different values from it. Equals 0. We're gonna jump. Oh, we would generate pulse 4. Oh, that command would be useful. I create a whole state machine for that. That's a very useful command. Um, Move ACC to X2. But it's greater than 0 loop. I want the 0. We gotta move ACC into X2. Then we deal with negatives. We're gonna sleep on X1, move X1 to AC. Test XC. We're gonna jump back to here. Yay. Otherwise, test XC. 4. Generate pulse 1 1. Add 1 jump 1. Okay, so he's using some fancy commands, so it's great. Is there any other beautiful? I want to see if there's any other stupid solutions. Yeah, I did something nasty like that. Yeah, what we got here about my solutions. The Three Kingdoms. Okay, let's see. He did that. Okay, I guess use the pulse command, which is kind of a special command. Okay, sorry, I got distracted. Well, thank you for watching. These puzzles, I like how they make you think of how to do different things in an embedded system. Join us next Wednesday. It doesn't seem like we actually have many more puzzles to go through, right? If we go through here, okay, we got about 10 more to go through, and then we're done. And then maybe we'll try a different game that isn't so hard to do at late at night.